Hello everyone and welcome to a new episode of All Things IDA. Just today, Hex-Rays released the domain API for IDAPython. These are a new set of APIs built on top of IDAPython, and the goal is to provide a cleaner, more Pythonic way to write scripts for IDA. As we dig into the source code, we'll see how those APIs are organized, what are the different database entities, and so on. Now, this is the first version, of course, there's not much to go for, but at least this will be a good introduction. With that, let's get started. First things first, this is the announcement from today. And it should be working with 9.1 and 9.2 release. The design behind the domain API is to create a hierarchy when you're interfacing with the SDK. If you've noticed, the IDAPython SDK is really mirroring the C SDK. Because of that, there is not a nice Pythonic way to program for IDA. Now, IDA utils historically tried to add those conveniences, but we cannot overload IDA utils. So here, Hex-Rays in fact address that, mentioning why didn't you put all of this in the IDA utils? Just because, again, it will not be very clean if everything goes to IDA util. Today, IDA utils can do functions in a Pythonic way, cross-references, dealing with instructions, decoding instructions, and whatnot. It's not necessarily super clean, but it was the way for a long time. And with the new domain API, that should start to clean things up. Now, I already installed the domain API from the repo, which this repo is 100% open source and contributions are welcome. And then you're required to set an environment variable, which I did, IDADIR, and I'm using the 9.2 beta for now. I could use 9.1 as well. After it's installed, you can see a bunch of examples. I'm gonna walk through examples at the end, but for now I'm gonna show you the source code real quick and describe it at a higher level. Alright, so this is just a standalone script here illustrating how we can open a database using the with syntax, so that will create a context and it will close the database when it goes out of scope. That's a Pythonic symbol, for example. Of course, this is useful if you are using IDA Pro or IDA as a library. That will make sure you don't forget to call db.close and so on. So behind the scenes, if we look at when we import the IDA domain, the init script will happen, and we can see eventually it is relying on the IDA as a library from 9.0 and 9.1. So the domain API is gonna, if you choose to, supersedes the usage of IDALib directly. So once you work with the domain, you import it. If you're in the user interface, then IDA Pro will not be used. Instead, IDAPython will be used directly. But this is seamless. You don't have to worry about this. And the same script will work accordingly. You can do your own check as well, whether you need to open database or not. Then the core element is database. And here we can see we have the database metadata. These are stuff we could have retrieved using the INF, IDA info header file. You can get the CRC32 and the pass and so on. I have a video on that as well on the channel about the IDA info. Here, IDA command options is a utility class that helps us build the command line arguments that we would normally pass to IDA, but here is programmatically we can set the attributes, and at the end the helper method build args will create the full IDA arguments that can be passed to IDA Pro or IDA as a lib. And then there is the database class, and this is the root object. We want to work with domain API. Our starting point is to get a database object. Once we have a database object, whether we open it or we simply create an empty object, which means we are dealing with the current database. So Then once we have the DB object, we can access things like the, here we see, for example, things like Xrefs, objects, signature files, bytes, manage hooks, types, and so on. And these really are related to the individual modules that I'm gonna be quickly skimming over. So we will notice as well, part of the organization here, they declare a database entity. And that word entity here, it will mean the objects that are really related to the database. We will see, for example, the names module inherits from entity, cross-references, instructions, comments, bytes, and so on. In the base as well, we will see a bunch of exception classes, and those exception classes tell us already what's gonna be the programming paradigm here. Most of the functions, as we will see, they will check for errors and they might raise exceptions if there is a failure. So it's unlike the previous IDAPython or the IDA SDK where there's no direct exception here. The terminology is fixed. We have to try catch or try except accordingly, because as we'll see, most of the stuff will be throwing exceptions. Next on the list, let's pick bytes for now. And inside bytes, we will notice they are creating some enum classes, for example, to hide the string types, search flags, byte flags. So these used to be global variables, and now they're wrapped inside classes. This makes the code clean as well. But we'll notice it's almost one-to-one mapping, except the names are slightly different. Then here we have the bytes, which is, as well as I said, it's a database entity. We can access the bytes from the database object, so we can say db.bytes, and once we have a bytes object, we can use methods to read bytes, even set bytes. So for example, get word at, get the word at, and also there should be put bytes, like set byte at, disassembly. If you've used the IDAPython SDK before, you notice these are really wrappers. There's no magic except trying to make this more convenient to the users. So we'll see if I scroll really quick, some of the methods, manipulating, reading stuff, patching or setting without patching, searching, finding immediate values, finding binary patterns, bytes. Of course, there are so many methods to wrap. This is the first version, so it's work in progress, but for now it's slowly building up to provide all the utilities you need. So most of these things are hidden and abstracted inside those classes for you. Comments as well is another module that is wrapping the comments methods. So we have a comment info class and we have the comments database entity, and inside it as well we can conveniently get a comment at a given address and what kind of comment, if it's regular or repeating comments, get all, set a comment, delete a comment, and so on. As well, it is lacking. There are anterior line, exterior lines that eventually can make it into that module. Basic blocks as well, we will see it's gonna be using the GDL, which has the flowchart object from the old IDAPython. And this is not directly manifested in the C++ SDK. This class as well is a high-level attempt to make IDAPython Pythonic back in the days. And so we can create or access the basic blocks from a database object, and then we can get the instructions given a block that will let us get the instructions through the database instructions object or entity, and get the instructions between the start and the end of the block. And we can also get a given block at a given end index, and once we get the block, here we get the flowchart, and from the flowchart we can get the blocks. moving on real quick to entries as well. This is mapping to the entry header file mainly. So entry.hpp in IDA, which deals with exported functions, entry point of the program. Here we can see an entry info, ordinal address, name, and so on. So as well, it builds on top of the existing entry functionality. So now you don't have to do multiple function calls in order to get an entry object. Normally you would have to get the entry ordinal, get the entry address, get the entry name, and so on. Now you get an object. So again, making things way more convenient and centralized. Functions, as you guessed as well. So that's the nice thing as well. This is not new to the domain API. This has always been the case where the header files are organized by name, descriptive name that describe the functionality. So in this module, the functions also wrap everything related to functions. So we should have functions entity, and inside it we can get a function iterator that gives us functions within a range, for example, or walk all the functions, or get add given an address, really similar to the get func given an EA. We see it, it's really just a single call. And pseudocode stuff, basic block, microcode, we'll see as well, like get microcode, get pseudocode, and a bunch of stuff. Heads as well, we have the heads in the bytes, usually bytes.hpp, get next head, previous head, tails, and so on. So if you've worked with the head APIs, then as well this is a wrapper. So we have test methods, iteration, next head, previous head. We have the hooks file. This does not necessarily map to a single header file, and it is a combination of all the possible hooks, or at least for now, the stuff that Hex-Rays implemented. So we will see wrappers on top of debugger hooks, Hex-Ray hooks, IDB hooks, processor hooks, UI hooks, view hooks. So for example, for processor hooks, we can receive commands such as processor module has been loaded or unloaded. For example, we should have the debugger hook as well. So expect all the hook related functionality between the callbacks that you should implement, well documented. So you subclass, you override the methods, and then you can add yourself to the database invocation and give it the hook. So when we construct the database here, we can give it a bunch of hooks, which the system behind the scenes will load the hooks and unload the hooks for us. So when we open database, eventually it will go and hook everything we passed in the list of hooks. Instructions, as the name implies, is another database entity that deals with instructions. So as well, we can retrieve an instruction and work with the classical instruction object. Now, maybe in the future they might wrap this as well, but for now, this instruction object is relying on the IDAPython, or specifically the wrapped version of the SDK, the C++ SDK instruction object. Names as well, we'll see it has stuff related to names, demangler flags, name flags, and the name database entity class, which we can retrieve through the database object. And here it lets us retrieve how many names in the database, to walk the names through an iterator, change names, delete the name, or retrieve the names, and so on. Operands is an operand wrapper as well, moves all the related enums from the IDA_UA into the proper enum classes. So again, this is an attempt to clean up and wrap things and unify things. Segments, as you guessed it, not much. Another database entity that lets us work with segments. Signature file as well lets us work with the signatures. This is mainly a utility function, not necessarily it maps directly to IDAPython. We can see some utility functions, enumerating signature files. creating them, even wraps the makesig plugin here through the create. It will invoke it and programmatically use an existing plugin and so on. Strings lets us wrap the strings facility so we can retrieve strings. This as well used to be in IDAutils. Now as well we have a clean independent wrapper for it. We have the strings database entity which lets us enumerate the strings programmatically in IDA. Types, I expect this file would grow a lot as well with time. This is supposed to wrap all the type information related stuff, getting prototypes, inspecting the types, creating types, dumping them, and so on. And finally as well, the Xrefs object is, as you guessed, deals with cross-references. This is something IDAutils used to have, and now it is its own wrapper here that lets us enumerate cross-references with certain kinds, code cross-reference, data cross-reference, and so on. Now I would like to talk about some initial observations I've had about this domain API. If we scroll a bit and look, we will see, for example, a bunch of functions, and we'll see other database entities have been decorated with check db open. It's not, doesn't matter really what's the decorator name exactly, that's not the point, but I'm trying to draw the attention of there's an overhead. So every method that we call, there's an overhead with respect to whatever this decorator is gonna do. So it might invoke extra functions each time. Every time we call something, it might want to call is database open. We'll notice, for example, if we're going to deal with another entity, let's say here, for example, the functions entity is, everything is decorated. And not only that, we will see if we are going to invoke a method inside one of those providers, let's say the functions, and we say, give me the functions between two addresses. As well, we will pay the cost of all those checks. And this is something to keep in mind if you're calling those wrapped functions in loops. There's that invisible extra check that you're paying the cost for. That might add up. I don't know. I didn't test for performance. But the previous IDAPython behavior and the SDK, also they used to have their own error checkings. They would return a bad address or Boolean and so on. And now we have an additional layer of checks on top of the lower level checks that are behind the actual implementations. And I did mention that now you have to recraft your code in such a way to handle exceptions. So exceptions will be thrown. Unlike the previous methodology where we can check for error codes, now you have to expect exceptions. And they are custom exceptions for IDA. So they are defined, some of them are defined in the base module, and some are in the actual module that we're dealing with. But expect this as well, that there is a hidden penalty, whatever that time it takes to do those additional checks, these checks are gonna be executed. Whereas here, if we're calling directly the underlying method, the checks are also happening, but behind the scenes. And now with the domain API, we have additional high-level checks. Quick, just a simple demo. I don't need to make much demos. There are examples you can look at. But this is a simple demo here that enumerates the functions. So for example, I start from importing from IDA domain API, the database entity. Since I'm inside the UI, I don't have to call open or anything. It's gonna leverage the existing database, and the code behind knows that this is the case. And here I'm accessing the functions entity inside the database, and from the functions can be iterated on, and we can get the functions. So here, for example, let's run it. We're simply calling the iterating. We get the function objects, and from the objects we ask for the function name, and we are calling db.functions get instructions list to convert the iterator to a list, just to count how many instructions. Very simple example. We could do the same in IDALib. Now, if I wanted to do the same workflow but from IDALib, normally, if before the IDA domain, we would do Python, we would import IDAPro, we would call idapro.openDatabase, and so on. Now we don't have to do that. We can just say import domain, and we call open the class method open. So we open database open. So that will guarantee here, the ways we guarantee that db.close is called when we leave that block. So we open database, we can expect an exception to be thrown otherwise, and we're doing the domain APIs to enumerate the functions. So this is a new learning journey, one can say. So notice here that I'm opening a different database since the one I open in the UI is still open. So normally, if I want to work side by side right now, for the scripting, I usually take a copy of my UI database just to test my script single step and debug it. And then I can run it in the UI or not. So for now, let's just run it and tell it what to open. So it's I hard coded that this different database, it will open it and display the same information. So here it is, it enumerated all the functions and displayed the instructions. Of course, we could have drilled down into all the basic blocks and the instructions, get the disassembly and so on. I'll leave that as an exercise to the user. I did notice with the IDA domain and also IDAPro package has been updated, and it ships with the Python stub files. So what that means is we can nicely get completion for the IDAPython stuff. So for example, here in this code, let's suppose I import, I'm still using the old Python stuff. So if I import IDAfuncs, now I can say IDAfuncs dot, and I have all those coming from the generated Python stubs that now ship with the latest IDAPro package. So here as well, I can have the hints and so on. So this is basically the stubs. If we open them, here it is. These are just the type annotation. So you can get the docstring and the prototypes. And if I wanna debug this real quick, this is the beauty of having IDA as a library. So if I put a breakpoint, let's say here, script started, you can hit F9, hit F5, debug the current file, and here it is, the debugger started. I can single step, and we can see the output here. So this is really useful. Now, just a small thing to note, if you have IDA 9.1, single stepping is broken and it has been fixed in 9.2 in the betas. So expect the full release of 9.2 not to have that single stepping issue. If you use 9.1, you can't, the moment you single step, the script will run. So just keep that in mind. If you can't single step, it's because there's a known bug. And finally, I have my own wrappers since a long time ago, and I never release it on purpose because I don't want people to adopt something like learn new knowledge that's not transferable. So personally, I might start to take code from my own private framework, which I called it IDAPython extensions, IDAPyX, and slowly move functionality and contribute it to the GitHub repo. That's the plan, hopefully. All right, so that's it for today. We covered the first version of the domain API for IDAPython. Hopefully in the future, with more developments, I get to show you additional stuff. Thank you, and I'll see you next time.